I forgot to record that earlier, so I want to redo it. Algebra 2, Lesson 7 of Module 2 is the secant and the cofunctions. So we got to find AD, OA, OB, and BD, and that will give us a tangent, cotangent, and secant and cosecant of these triangles. And we know that all these triangles are right triangles, and they're all similar. So what we're going to look for is AD. Okay, so that's this leg. Well, AD can also be paired with OD to give us the two side lengths of these triangles. Okay, and what are those equal with the triangle that we know the sides, or know the hypotenuse and all that type of stuff? So that little triangle that's actually inside the unit circle is what we want to compare it to. So CD will be what whoops. Yeah, sorry, I don't know why that looks like that. Okay. So AD is the hypotenuse. Well, that's going to look like the hypotenuse on that other triangle, DO. And OD is going to be the same thing as, well, let's not do that, because we've already compared it to the other, the hypotenuse of that, so we don't want to do that. Let's say D or AD is the same thing as CD, this triangle leg, okay? Which means that it has to be equal to this leg of this triangle, which is going to be OC. So we've got the two legs of the triangles compared to each other. Now, what do we know? Well, we know DO, so we can say AD over 1. Okay? And that's going to be equal, well, what is CD? CD is sine of theta. And OC is the cosine. Okay? Now, what is sine over cosine? Well, that's tangent. So AD over 1 is equal to the sine over the cosine. So this is going to be the tangent of theta. Okay? Now, OA, let's look at OA. OA, let me go ahead and clear this off. OA is the hypotenuse of this triangle, right? Or it could be the base of this triangle, right? So that's where it kind of gets confusing. You got to figure out what you want to use it as. So we're going to say OA is the hypotenuse for the triangle. So this would be AOD. Okay. Now, we can also say that it's going to be compared to OD and OC. Okay, so the hypotenuse and this leg. So we have the hypotenuse and this leg of those two triangles. So it's all about how you can reason these triangles to be. Now, what do we know? Which one do we know? We know, well, OD is 1, so we have OA over 1. OD is 1. And so that's going to be equal to what? What do we know about this? Well, OD is 1. And so we're just moving these over. OD is 1. What is OC? OC is the cosine of theta. Now, we know then that OA, this is equal to 1 over the cosine of theta. Well, what is the cosine of theta? That is equal to the secant of theta. Okay? It's equal to the secant of theta. All right, let's look at this next one, OB. Okay, so we're going to look at OB, and we're going to compare it with, let's see here, OB. Okay, it's this long leg. We can compare that with, oh, well, not compare it with, we want to find the other leg of the triangle, and it's going to be OA. Now let's compare it to the other triangles. Well, OB is going to be equal to, let's do this leg of this triangle, OC, the long leg of this triangle, which means the other one would have to be AD or, no, CD, sorry, CD. Okay, the short leg of the triangle. Short leg of the triangle, short leg of the other triangle. Long leg, long leg. Now, once we're done with that, we say, what do we know? Well, all we know right now is OB. So let's start with OB. We don't know OB, but OB is equal to OA, and we know what OA is. OA is the secant of theta. We've already established that. Secant of theta. It's right here. Now, we would say, what is that equal to with OC and CD? Well, OC is the cosine of theta, and this is the sine of theta. Okay? And this may be where it gets a little tricky for you. Okay? Since we're trying to find OB, okay, what would we do? We would multiply by secant of theta and multiply this by the secant of theta. Well, when you do that, that's the same thing as saying 1 over cosine, right? So we would have cosine over sine times 1 over cosine, which means those two cancel and leave you with 1 over the sine of theta, which is the cosecant of theta, because that is the inverse of sine. Okay, now I'm going to move over here and do BD. BD, so what is BD's other leg? BD's other leg would be OD. All right, so and on this triangle, it is the long leg, so that is again OC over CD, the short leg, long leg, short leg, okay, which is going to be what? What do we know of these? Well, we know that OD is 1, so we have BD over 1 is equal to, what is OC? Well, that is the cosine of theta over CD is the sine of theta. Well, BD then is equal to the cosine over the sine, and that is simply cotangent. This is equal to the cotangent of theta. And so that's how all those are done, and hopefully that will help you if you come back and look at it.